Hello Titan Dev Team, just a quick one on setting up foliage interaction for the project. So I've got a quick demo that I've put together here to show how it works. We have our main player character with a nice radius around us where we squash down all of the foliage. You can see that it kind of rotates around them. But then we also have a trail as well that works. So you can see as we run around, the foliage behind us will slowly get back up. But only after a certain period of time. The way that this works is reasonably convoluted, like most tech art things are, but it's pretty easy to set up. So if you have your asset, which I have the demo one over here, so ideally we need a pivot to rotate around, which is how this generally works. So we can basically take this point, and as our player gets close to it, we can compare those two positions and then we can rotate our asset away from it. But as you can see, that doesn't really work when we have an axis like this, because we have lots and lots of points that we technically need to rotate around. Now, you could do this by just creating one of these with a central point and then scattering those, but that's going to make a lot of instances. So the way around that, or the kind of hacky way around that, is by basically faking pivot data. You can do it a number of ways, but one of the nice quick and dirty ways that I tend to do it by is just by doing this projection method. So all you need to do is set up your assets like this. So you have all of your assets, create a 2 by 2 meter plane for them to fit on. They can technically fit outside of that, but you'll need to modify the function that I've created in order to set that up. And then just go into your top-down view, select the whole asset, press U, project from view. Again, I'm doing this in Blender just because it's a nice open program that anyone can download, and then tick scale to bounds. And what that will do is it will map this to my UV square, which I have here. And then all I need to do is go to my bounding, my center point, and set that to individual origins. Then scale that down. We can actually just press S and then press 0, and that's going to scale all of these assets down to their local bounds that we have here. And now you can see each of these squares has now been assigned to basically a point in space in the UV coordinate. So I can now use this to create a unique pivot point for each of these items. And that's exactly what I've done here. So inside the Blender file, I've just got a separate UV channel. So UV channel 1 is what it expects you to be using, which just stores the pivot data. And you can see now on my asset, the foliage wind, which uses the same logic, is now rotating each of these points individually rather than it doing, kind of it like that, which is how it would have to do it otherwise. So reasonably simple to set up. All you need to do is make sure that you've got that in the correct UV channel. You've scaled the UVs correctly so that they represent a good point, and they're limited to, as again, by default, a 2 by 2 meter square. So as long as you've set that up, you should get this working, and it should also work for foliage interaction as well. You will need to add this material function as an additional extra to your material. So again, it's inside base content, environment, global, materials, and M functions. Inside there, you'll find a foliage interaction material function, and you'll find a wind material function as well that you can use in your scene. There's also this scene set up for you in foliage interaction demo, so you can open that up and have a look. And you can also look at how it's set up on this specific example here. So you can see that, again, very, very simple, trying to keep it as easy as possible to implement. So all you need to do is add whichever wind and movement functions you want in. So there's a foliage interaction point here. If you come up with your own methodology for implementing pivot positions, you're welcome to put that in this point here. But by default, it expects to use the texture coordinate to basically offset its origin. So the way that this works is, again, we take UV coordinate 1, which are those points that we made in space. We minus that by 0.5 and multiply it by 2, which just brings it from the 0 to 1 range to the -1 to 1 range. Multiply that up by 100 and then transform that from basically this local space to the absolute world space per item. So that basically takes this pivot, and if you imagine that texture coordinate wrap that we've just done there, it basically just offsets each of those points in space so that they map correctly. And that's all this logic is doing here. And then we've got a bunch of other maths that basically, we use a right texture and a sphere mask to basically kind of like create that rotational correctness on our items, so that you can kind of see that here. I won't go too much into the actual setup for it. You're welcome to look into that yourself to see how it's done, but I will direct you towards the correct areas just so you're not kind of stumbling around. Inside blueprint and character, if we open up our main character set, we have a dynamic material instance here, which is called update foliage. And then in our event tick, we basically set two vector parameters. One is the current player position, and then the other is the previous player position. So basically at the start, we get player position, set it to previous, and then set our new player position. We can then use those 2 points to basically interpolate between the previous and the new location that we have in there. We then draw the material to a render target. So for this, we're not actually using a scene capture, but we are using a very small 256 by 256 render target, which is this one here. The RNG channels basically outputs a direction, which we can then use to warp the foliage. And then the blue is a mask that we use to basically control how much it's affected. So that's the base logic. You'll be able to find the materials in here, inside blueprint and foliage interaction, so that you can see how that stuff is set up. Again, it's reasonably cheap and simple. It does operate on the CPU because we are writing it via blueprint. You could technically write this through Niagara and do it as a GPU grid sample, but this is a much simpler implementation. It's much easier to understand, so which is why I've kind of gone for that method instead. But for basic foliage interaction, this will work well, and it also has a good fallback as well. So we can technically we can strip this out and this out, and just write the player location, and then inside our foliage material, if we go back to that, we've put in let's go over to foliage interaction. We've basically got a quality switch in here, which switches from the render target, which obviously has the trail, over to basically a single sphere mask. So rather than sampling the texture and having to write to it, we just simply write to the sphere mask instead and use that, which is again much cheaper. So that's the kind of that end effect. Hopefully that's useful, and if you have any questions, feel free to post them in the Discord.